Hey everybody, Stephen Ramsden, director of the Charlie Bates Solar Astronomy Project, coming to you live from Atlanta, Georgia. We're just a couple of days away from Hurricane Irma coming through, destroying Florida and most of South Georgia, and we're going to broadcast the sun. There's a fantastic active region, AR2673, that's been blasting out X-class flares for the last couple of days, and we're going to hope that we see one here in the next couple hours. And I'll broadcast it until I lose the sun. And if you want to join in, and it's still live, there'll be a link on my Facebook page. And we're going to start out with calcium K. We're using a 6-inch Esprit Skywatcher USA Esprit triplet for our calcium and white light, and we're using a 6-inch double stacked hydrogen alpha scope for the H alpha. We're going to start with the calcium, and you know the routine. Facebook, chat, whatever you want to do, and welcome to the show. So let me share this calcium screenshot with you. And there you go. It's pretty amazing active region. It's been there for about 4 days now. The one on the lower right, and it just appeared out of nowhere. Formed up and has just been thrilling all of us nerds for days now with its output of X-ray radiation. It's really a fantastically active region. Not to mention AR2674, which is just above it, not getting any credit. It's a massive sunspot, really Jupiter-sized sunspot, but it has not been flaring as much. Let me try to get the focus a little better. Yeah, that's pretty good. Of course, this image is in monochrome, which is what all solar astronomy is actually done in, all astronomy. We'll throw some color on it in a minute. I know people like to see color, but just check out how incredibly awesome this is. It's really amazing. Okay, so here you go, color lovers. Boom. This is pretty close to the actual color. See if I can get the image nice and cleaned up for you in high contrast. No X-class flare right now, but we're going to monitor it for a couple hours here and see what happens. And if you're joining us after we've already done this live broadcast and you're watching a replay, what the heck's wrong with you, man? Get on here and join us for the live broadcast. Yes, I misspelled live in the title of this video, but I have went back and edited it. Oh, saw our first airplane fly through the scene. Fantastic. Hopefully we'll get a bunch more of those. Yeah, that was pretty awesome right there. That aircraft was heading to the southwest, probably getting out of Dodge for the hurricane. All right, I'm going to get out the Barlow lens, get a little zoom in. Let me go ahead and mute the mic while I do this. Everybody stand by. All right, let's get some focus going on here, see what we can do. I'm sitting in my driveway in downtown Atlanta. All right, there we go. Not bad. Let's turn it down a little bit. Exposure's a little high. There we go. Now, using a AP600, I'm sorry, AP1200 mount. Pretty rock solid mount. I just roll it out into the driveway and start broadcasting. It's worked pretty good over the years. All right, see if we can get the focus any better. The seeing is not nearly as good now as it was earlier in the week, but I think we can do a little better than what we got. I'll go ahead and turn the color off because it's just a distraction, really. It's much more beautiful in monochrome. There we go. Got a little spot here. Yesterday, this whole region was filled with flares, M-class flares mostly, with an X 1.4 went off yesterday morning. Today it's a lot quieter, but let's see what happens because things can change instantly when you're watching the sun through a telescope. No one can predict it. And before you know it, you might have a X20 flare pop off the sun. We'll wait around and see. In the meantime, I'm going to take a few video runs of this. We had an aircraft fly through the field of view right off the bat this morning, which is always a good sign. Hopefully that'll happen again. I live near Atlanta Airport, about 16 miles north, so we always get descending air carriers coming in here, and depending on the flight pattern and what direction they're landing at the airport, we can get several jets taking the ILS inbound to land on Atlanta, landing west. So we'll see what happens. I'm going to go ahead and mute the sound again, and I'm going to paste a link on my Facebook page for anybody that wants to join. Yeah, the seeing is about 4 out of 10. Very shaky. We're operating at f20 right now through a 6-inch refractor, and we're getting all sorts of movement. But we'll keep going and see what happens. I'm going to turn the exposure up now and see if we have any calcium prominences to look at. Nope. Back down. There's a couple of new spots, of hot spots right here and here. I'll see what happens with it. As always, we want to thank Coronado Solar Telescopes, Celestron Telescopes, Skywatcher USA, and Rainbow Symphony for sponsoring our program, making all this possible. We're starting our big fundraiser 7 days from now, September 15th. We're going to give away a big, giant 14-inch collapsible Dobsonian telescope from Skywatcher USA. And stay tuned for posts on that on Facebook. I'm going to go ahead and mute it again for a little bit. Then we're going to go over to hydrogen alpha shortly. I've had some comments that it looks out of focus. Yeah, it does, because the seeing here today is terrible. We've got a hurricane coming in, but I'll attempt to focus it a little better. That's about as good as it gets right there. Rafael Colon Romano is on from hurricane struck Dominican Republic.
There is another one on the way. Jose.
Yes, I understand you're going to get battered again. This is probably going to be further north from you, though. The seeing conditions today are a lot worse than yesterday, but we're doing what we can.
Yeah, we have a lot of big wind. It's crazy this weather.
So you're still getting strong winds there?
Yeah. Maybe
I'm
I
working
can
on the
show.
focus.
So Stephen, after your hangout, the flare went off, I guess.
Sorry about that. We had the FedEx delivery man was here, and I was giving some solar outreach to him. I had to put you on mute. So I'm going to go on over to hydrogen alpha after this imaging run. We'll see what it looks like. Chris Fernandez says he can hear you, Raphael, and your family.
Where is he? I can see him.
He is not on the call with us. He just text messaged me to tell me that.
Okay.
Chico, venga. Chico, Sebastián,
Okay, now we're going to switch over to hydrogen alpha. Okay, so here we are at hydrogen alpha view. We're at F18. Little Newton's rings going on, but I've got the gamma turned way up so I can catch any spicules or proms that may be off the limb. And then I'll turn it back down here shortly. Looks like there's a little flaring region right here, C class, and nothing going on with AR2673 yet, but you never know. It could pop up any second now. So let's just keep watching this and see what happens. I'm going to mute the microphone now. This is an inverted view inside the software. It just reverses all the values for the brightness. So anything dark black in this region is a flare or a developing flare, and anything white is a sunspot. And the varying degrees of white and black indicate inverse temperature. So the darker it is, the hotter it is. The inversion allows you to see a little better. All right, I'm going to switch over to the white light view here in just a moment. So let me mute the microphone. Before we go, there's a nice little spot heating up right here. And we'll come back and check on that in a minute. All right, looking pretty good in white light. And as always, I use a Celestron number 58 green filter over my camera when I'm shooting white light. That's pretty good. It's a beautiful active region. The sunspot grouping is really phenomenal. It's a beautiful piece of physics floating up in the sky right there. Thermodynamics, electromagnetism, heat, conduction, convection, and of course, incandescence. Let me mute the microphone for a little bit while we watch this. That was a satellite that just went through the image. So once this imaging run is over with, we're going to go back to hydrogen alpha and check out the flare situation. As you can see, the seeing is terrible, but it's still pretty cool to watch. So everybody stand by while I switch back over to H alpha. So this area here is just getting brighter and brighter and brighter on this small sunspot, AR2674. And this is the hottest part of this image right now. So maybe it's going to blast one out. AR2673 is being fairly calm except for these bright flaring spots here, or exit points, as Gary Palmer called them recently. So let's keep watching and see what happens. Well, what do you know? There's a flare coming off the top of AR2673 right here. That's a hot one. Hopefully that's going to expand greatly here shortly. Keep your eyes on this region. And here we go. This one just popped up here just a few seconds ago. And here. So this looks like a big one, everybody. I've been watching these for a while, and this looks like a big one. So let's all stand by and check out what happens. I'm going to try to zoom in. All right. There we go. Let's get our focus just right. People's, this is a flare. It's grown twice its size in the last 40 seconds. Look at that monster. Holy mackerel. Look at this one. That's an X-class flare right there. Look at that. It's 3 times its size in the last 2 minutes. You're watching this one live on the Charlie Bates Solar Astronomy Project Driveway Solar Cam. And I'm glad to have you. That thing is huge. That's about 3 Earth diameters right now. Excuse me. Yeah, that's a big one. That's a big one. And you 3 viewers out there that bothered to tune in and watch, this is a super treat. This is awesome. See if we can get the focus better. The seeing conditions are deteriorating rapidly. Come on, flare.
Oh, whoa.
Yeah, it was twice that size 3 minutes ago, and we're hoping that it gets bigger. We're waiting to see. Okay, thanks to those of you joining from Phil Plate's tweet. Thank you, Mr. Bad Astronomer. The region that's super bright right here is oversaturating the camera. It's about 2 million degrees Fahrenheit. And it was about 3 times that size. It looks like it may be subsiding right now. But stay tuned, because we had 0 warning of this flare. It popped up in about 45 seconds, blew its X-ray radiation out, and now it looks like it may be subsiding, but we're going to keep watching it because you never know what's going to happen on the sun. Thanks, Phil Plate, for the tweet. And anybody watching can go out and do this and take images of this with no problem. You can have your own solar live broadcast in a matter of about an hour of messing around with the equipment. So don't let anything in this hobby scare you away. Anybody can do this. Let's go back out and get the wider field view, see if anything else is going on. So this is AR2673 here. This is AR2674. And this region here flared a little while ago, a little C class, maybe an M class. And now this region just popped out what had to be an X class flare. I'm still waiting for somebody at NASA to make a determination on that. All right, I'm going to put it on mute so you guys can watch it without me distracting you. Those of you that just tuned in, we're doing a live broadcast from my driveway in Atlanta, Georgia. And this is a 6-inch Skywatcher USA Esprit telescope with a hydrogen alpha filter and a point gray grasshopper camera. These two active regions here, this is AR2673. Very interesting features right now. This is a flare right here going off. It's subsiding a bit, but I'm expecting it to blow up again. All these little bright white dots in this area, those are potential flaring regions. Anything bright white means super hot plasma. The dark areas are sunspots, and all this white region around here is much hotter than this dark area. This was a flare that went off just a little earlier and it's calmed back down. But the hot spot right now is right here, and this is the same place that unleashed the X 9.3 class flare 2 days ago and an X 1.4 flare yesterday. About 20 minutes ago, we saw it blow up with another flare that probably hit the X1 level. Not sure yet because the important people haven't made a determination on it, but I'm waiting on somebody to tell me how hot it got. But it's still flaring. It's still in the M class region. What is a solar flare? Well, that's when the sun's magnetic fields interact so strongly and you get similar polarity fields. The energy has to go somewhere. So they shoot their wad up above the photosphere, they reconnect similar polarity fields, just like pushing a magnet together on the North Poles when you're in school, the repulsive force you feel. We'll multiply that by about 2 billion, and that energy is released at the reconnection point here above the photosphere. And we see it as super, super, super hot plasma in the millions of degrees. These dark lines up here are because my camera is running at about 200 degrees Fahrenheit right now because I'm out in the bright sun in Atlanta. These are called Newton's rings. But this region right here is popping with activity right now. So if you stay tuned for a little bit, you may see another one go off. This one's subsiding now, but it was 5 times that size 20 minutes ago with no warning whatsoever because we can't predict these things. So you just have to watch and wait for it to happen. So I'll keep broadcasting it until I lose the sun. I'm in the middle of Atlanta, so there's tall buildings all around me. We're looking in between 2 buildings right now. But thanks, Phil Plate, for the boost. We've got 21 viewers now live, which is, believe it or not, the most people that have ever tuned in to view any live broadcast we do. We do this every day. We've been doing it for 10 years at schools and all other types of places, and we might have 2 viewers, 3 viewers at the most. We've currently got 23 viewers thanks to Phil Plate and his tweet. So I encourage you to get into solar astronomy. It's a fantastic hobby. I'm going to put it back on mute so you can listen. And our main website is solarastronomy.org. And this is Stephen Ramsden, the director of the Charlie Bates Solar Astronomy Project. Thank you for watching. I would suggest staying tuned for a little while longer because you never know what's going to happen. By the way, this little dude down here, Raphael, is our Dominican director of the Charlie Bates program. He's got a hurricane currently over his house, and he's tuned in watching. So what's your excuse? All right, Stephen Ramsden again. Those of you that just tuned in, we are watching AR2673 and AR2674 through a 6-inch hydrogen alpha telescope using a monochrome camera and some Mac software called Astro IIDC. So let me show you what this flare looked like just 20 minutes ago. That's me, by the way. Hey. This is just a screenshot from the flare when it went off. Notice this super bright hot area. This is a M or X class flare that just exploded out of nowhere, no warning. Within 45 seconds, it went from nothing to this super bright flare that was ejected from AR2673. So that's what we're waiting for. We're waiting for another one to happen. Howdy. And here's the live view right now on the sun. And well, as live as you can get, we're looking at light that left the sun's photosphere 8.5 minutes ago, traveled through our hectic solar system, went through our atmosphere, and is now entering my camera. And you're seeing it live on the internet, which is freaking fantastic to me, by the way. So we're going to watch it a little bit longer and see what happens, because there are several small flaring regions that are building in this active region right here. An active region is a magnetically active region on the sun. All the dark things here are a little bit cooler, and like this is a big prominence that's just being jetted out of the center of this sunspot. Here's another prominence curling around the bottom. This is the sunspot itself. And all these little bright regions right here are places where magnetic energy is being stored and just waiting to explode. Same thing's happening up here on this sunspot, AR2674, and right over here. So we've got 3 different regions where flares may occur at any second now. And we monitor this every day through my program and broadcast it online. And we've got people in 27 countries, like that little dude down there at the bottom of the screen, Raphael. He can wave at everyone. Hey, Raphael. He's in the Dominican Republic. He just had a hurricane go over his house, and he's still monitoring yesterday and today. And we're going to continue watching and hope for another gigantic flare to come off on the sun today.
There is something interesting that the sunspot is a little bit cooler, but if we could take out this little black spot from the sun, we bright the same way the sun bright.
Yes, you are very correct, Raphael. It would be about 5,000 degrees Fahrenheit, but compared to the rest of the sun's photosphere and chromosphere, which is 10,000 to 2 million degrees, the sunspot appears to be cool. But if you took the sunspot off the sun and put it out here in space, it would be brighter than the full moon. So these are all fantastically wonderful things about the hobby. And not to mention that this sunspot itself is about 4 Earth diameters long. It's about 20,000 miles long. This flare, or this prominence right here shooting out, is almost as far as the distance from the Earth to the moon. And if you put the Earth and the moon in between these sunspots, the moon could orbit the Earth without touching either one of them. If the Earth was right here, the moon, the entire orbit of the moon, would fit in between here without touching any of the sunspots. So we're looking at absolutely gigantic features, super, super hot features. And as you can see down here, there's another bright spot there that looks suspicious to me. And we are waiting to watch it blow itself off the surface of the sun. By the way, we're in Atlanta, Georgia, downtown Atlanta, so all this movement in the sun is being caused by our crappy polluted sky above Atlanta. Look at that. Boy, it's just changing every second right in here. I mean, every time you look at it, it's different. This region here is firing up again. These are two very small sunspots. Well, I say small. Both of these are bigger than the Earth, but small for the sun. And if I turn on my saturation indicator, it tells me where the brightest parts of the display are. And this will indicate where the actual flares are. So this spot is the hottest part of the display right now. And we're waiting for this to blow up again. So I'll stop talking now so you can enjoy it, but everybody just stand by. If any of you would like to join in on the hangout and hang out with us and talk, just my Facebook page, Charlie Bates Solar Astronomy Project, is a Facebook group. And my name is Stephen W. Ramsden, Stephen W. Ramsden. I'm the only one on Facebook. And there's a link right there for anybody to join in, because we love to have amateurs and new people come talk to us. And this is all being done free for the general public. So feel free to come join in. Okay, everybody, if you haven't noticed, this region here is now getting super hot, and this region here is staying super hot. So keep watching. You never know what's going to happen on the sun. It's impossible to predict when a flare is going to occur, but the chances are extremely likely for an X-class flare today from one of these two active regions. I've just turned on the color so you can get a little better feel for the fire going on. The actual color of this wavelength is red, 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 but it's hard to see on a computer screen. So I use orange, 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 orange as a method of which to give you a little bit higher contrast, a little better feel for the hot nature of what you're looking at. This is an absolutely awesome thing to look at through a telescope, and it's extraordinarily simple to get into this hobby. Anybody can do this in less than an hour with the right equipment, and you can take this out to your local schools or public and share this with the people, and they absolutely lose their mind when they look through these telescopes. So it's still new enough for you to get out there and start your own program. But this is our sun, a G-class average size yellow star made of approximately 74% hydrogen, 25% helium, 0.9% every other naturally occurring element on the periodic table, up to uranium. And the core of this star is powered by nuclear fusion, which is just gravity pressing the hydrogen together so hard that it fuses, explodes, and produces helium and lots of energy. And what you're looking at now is called the chromosphere of the sun. This is the part just above the surface, just above the photosphere. And the chromosphere is where you can see solar prominences, solar flares, things of that nature. We're looking at a single wavelength of light coming from the chromosphere, 656.28 nanometers. It's called hydrogen alpha because this is the emission line produced by the hydrogen atom. And by emission line, I mean this is the light. This is the wavelength of light that's produced by the hydrogen atom when its electron goes from the third level to the second energy level in its atom. So this is happening trillions of times a second in the chromosphere, and you're looking at light being emitted, individual photons being emitted by the hydrogen atom. The atom gets energized by the core of the sun. The electron jumps from the second to the third energy level, and then it immediately releases that energy at the same wavelength. So you get an absorption line in the spectrum, a black line where it absorbs it, and then you get a re-emission line at the same spot in the spectrum. And this telescope is designed to see only that wavelength of light. Nothing else is visible in this telescope. So that's how you get these fantastically awesome views. You're looking at hydrogen atoms emitting light in the sun's chromosphere. What does that mean to you? Well, this is where life comes from. This is why you're alive. This is the most important thing in the universe to your survival. Whenever you look at something outside, you're seeing a reflection of the sun when you look at it. Every day you wake up, you're alive and breathing because of the warmth provided by the sun. This is the most important thing in the universe to our daily survival, yet most people have no idea what it's made of or how it works. So get into this hobby and join us at the Charlie Bates Solar Astronomy Project, solarastronomy.org. It's a really cool thing to do, and we'll show you how. Those of you that are just joining us, this is me. Let me show you this photo. It's just a screenshot that we took during the flare that occurred about 40 minutes ago. That's it there. So what you're watching live, about 40 minutes ago, this massive area about 3 times the size of the Earth just exploded with X-ray radiation, spewed it out towards us, and produced a solar flare, probably X-class solar flare. So we'll go back to the live shot now, but that's what it looked like just a little while ago. And there's no way to predict these things. So I suggest you keep watching and see what happens. That's my neighbor backing his car out in the driveway. I'm in downtown Atlanta. People walking by, they think I'm insane because I have all this gear out on the street. And there's tall buildings on either side of me, and everybody just kind of walks by and looks funny at me. Sometimes people will come up and say, "Hey, what are you doing?" And then I get them in here and they take their own photos of the sun. It's very, very simple. I'm going to turn it back to monochrome so you can see the actual data coming from the sun rather than this false colored version of it. So there you go. That's what it actually looks like in the camera. And this is a monochrome camera because we're only using one wavelength of light from the sun, so there's no point in trying to take a color photograph of it. And we're watching to see what's the next region that's going to flare up. So this region here has got a little bright spot in the center. It's getting brighter. And this region here and here is likely to produce flares today in the X class. So let's keep watching. It's 3 p.m. here in Atlanta, and it's in the upper 80s right now. And the camera is currently operating at 160 degrees Fahrenheit, so it's not happy. But the seeing conditions are deteriorating rapidly, and we're trying to keep it in focus, but it's just heat rising from the Georgia pavement is playing havoc with everything. So stay tuned, and we're trying to get it focused a little better for you. But this is a cool image as well. Well, look at that turbulence in the atmosphere. It's terrible. On a positive note, this region down here seems to be getting really hot. There's also a layer of pretty light haze has just moved in, which makes it even worse. But, you know, it's like fishing, man. Sometimes you get good conditions, sometimes you don't. And we caught a pretty good fish earlier, and we're waiting for a 10-pound bass to get on the line so I can set the hook. So stand by. We still got another 40 minutes or so before the sun goes behind the building, and we're going to watch. To me, it's very interesting to watch this region and all the little super hot plasma bubbles appear and go away.
Ya. Ya.
Hola, Stephen.
Hola, señor. ¿Cómo está?
No soy yo, soy Seba.
Ah, bien, bien. Sí.
¿Tú sabes quién es?
He's asking if you know who he is.
Yes, I do know who you are. You are the robber that's robbing Raphael's house right now.
Ay, yo no entiendo nada de lo que dice.
You are the gringo.
Dice, ¿qué significa eso?
Okay, so it looks like we saw one big flare an hour ago, and now the clouds are moving in and the sun is going behind the trees. So adios to my Dominican director, Rafael Romano, and we'll check in again tomorrow. If Hurricane Irma doesn't get overhead, we're going to try to broadcast this again tomorrow. I think we may have one more chance to see this before it goes around the edge. So thanks a lot for watching, everybody, and we'll see you tomorrow.